Hi everyone, in this section we will create a second web client to show how Keycloak enables single sign-on for two applications that shares the same realm, which will actually be an identical of the first web client. We will only change the port of the service and also change the Keycloak client ID, client script and redirect URI configuration properties. So let's create an identical web client called Elastic Query Web Client 2 and copy the POM.xml file. Just change the Docker image name here. Then copy all the files under Resources folder and change the Bootstrap YAML file to set the new name and new profile for this client. Also update the logback.xml file with the correct application name. Let's then copy all the source files to the web client too. We do not need to change anything in source files. Then we will create the corresponding config file with webclient_2 for this new client and change port to 8185. And also set client ID and secret for the second client by getting it from Keycloak. I will also encrypt the client secret using Spring command line utility. And finally update the logout redirect URI and change the port to 8185. We should now commit and push config server changes. Now please run config server. Also make sure Elastic cluster is running locally. Then run Elastic Query service. And then run the client that runs on 8184. Then also run the new web client that will run on port 8185. Now if you open browser and log into web client that runs on 8184, then open a new tab, go to the new web client that runs on 8185 and click on login button. We will see that it's automatically logged in. As you see, by default, multiple clients with same realm can use single sign-on. If one client logged in already, second client that runs on same browser, no need to log in again. For the second web client here, no session attribute with name Spring Security Context will exist, so a user still be redirected to Keycloak server when we try to log in. But it will see that realm has active session and authenticated, so it returns the authorization code directly without asking user credentials. And this authorization code exchanged by tokens with a backend call on the second client, and then client 2 is automatically logged in. Note that if you log out from one of the clients, other will also be logged out. Here we see that we have two active sessions for the microservices realm on Keycloak. But again, for this to work, clients must be in the same browser. A cookie called auth_session_id is used on Keycloak site, along with the realm name, and then it determines an already authenticated session in Keycloak. So with another browser, user need to log in again. Here we can see the cookie that is checked by Keycloak on the Chrome developer console. This is like same application uses gsession_id to get user information on different tabs and creates different sessions for different browsers. In our case, we have two different applications, but on same browser, they can share the logged-in user as long as they share the same realm on Keycloak. We can now run maven install command and create all Docker images with the latest code changes. Let's now try to run everything inside Docker, including authorization server and the new SSO client. We need to do some changes on Docker Compose files. First of all, I added a file called check Keycloak server started.sh and check if Keycloak is up, which is required to check before running query service and the web client. I will now change the config server check file and at the end of the file, call the Keycloak check file. And in the Keycloak file, I'll call the lifecycle launcher to continue running the Docker image. Note that we don't need to install curling Keycloak check file as it is already installed while checking the config server. Now let's run Keycloak Docker image and open the admin console. Here we will change the localhost definitions with the Docker host names. Since we cannot use the localhost for the Keycloak anymore for the other Docker containers, and instead we will use Keycloak Docker hostname, it would be better to change the all localhost definitions to host names to prevent confusion. So set Elastic Query Web Client 1 and 2 and also change the query service definition to Elastic Query Service 1. So instead of all localhost definitions, we entered the Docker host names. So on browser, also we need to use host names now. Because when user redirected to Keycloak, it cannot use localhost anymore, because localhost will refer to the container that's running. So we will use the hostname for Keycloak Docker container. And to reach this hostname on our local browser, we need to update DNS definitions. So please go to your host file and insert mapping for the Docker hostnames to localhost. Now in the services YAML file, first we will add Keycloak image and change the port to 1991 because the previous port 8081 is used by Kafka schema registry. Here we use the same environment variables and set the network as global network like in other Docker service definitions. Then let's set the second web client, which we used to try single sign-on. This one has image name that ends with .2. For HTTP port, I will give 8185, as we set this in Keycloak admin console. Now in volumes, we will map the Keycloak check file also. In the environment variables, set the load balance query services instance ports to 8183 and 8186, and also set the OAuth2 Keycloak issue URI to refer to Keycloak Docker image hostname. And finally update logout success URL and set it to Elastic Query Web Client 2 instead of localhost, as we will use hostnames on browser now. Let's also update the Web Client 1 with the Keycloak check file and also set Keycloak issue and logout URLs. Finally, for query service containers, again we will set Keycloak check file, then update the port for the second service to 8186, as we configured web clients to connect to 8183 and 8186 for query service. And then also update Keycloak issue URI and GWK set URI to refer to Docker hostname of Keycloak container. And also for PostgreSQL connection URL, we need to set host Docker internal to be able to connect to host machine, as we set in the Keycloak container environment variables. One important point is that for the second instance of query service, I will now set the data source initialization mode to never, because if both try to create schema and insert data, we may end up initialization errors, as when one try to insert data, other would drop the schema. For this run, you can command out Twitter to Kafka and Kafka to Elastic services to reduce the memory load on your machine. Alright, we can now run the Docker Compose up command. And after all containers are up, try to log into web clients and query the Elasticsearch. Everything should still work, including single sign-on. Great, congratulations! You really did a great job so far. Next section, we will make an introduction to Kafka streams and write another microservice to introduce the concept. Alright, I will see you in the next section.